Thank you to everyone for being here with us today. For those of you who don't know me, my name is Avery Slater. I'm assistant professor in the Department of English at the University of Toronto. I'm also a faculty fellow at the Schwartz Reisman Institute for Technology and Society. Before we begin today, I'd like to take a moment to acknowledge the land on which the University of Toronto operates. For thousands of years, Toronto has been the traditional land of the Huron-Wendat, the Seneca, and most recently, the Mississaugas of the Credit River. These and other Indigenous people across Turtle Island developed complex and effective governance systems based on respect for all life and the intelligence of the natural world. Today, this land is still home to many Indigenous people working to reclaim their rights to self-determination. We're grateful to have the opportunity to live and work on this land. Although we're joining from different places, we invite you to reflect on the history and relations of the land that you are on. So a few logistics as we begin. This session is recorded. The talk will last for about 50 minutes, and after the talk, we'll take questions. During the Q&A portion of the seminar, we encourage all participants to use the raise hand function in the Zoom meeting controls to ask a question. You can also put a short version of your question in the chat if you'd like, and I'll call on you at that time. So I'd like to introduce today's speaker, Marzieh Fadaee. We're very delighted to have Marzieh here. Marzieh Fadaee is a senior research scientist at Cohere For AI. Her work is broadly interested in all aspects of natural language understanding, particularly in multilingual learning, data-conscious learning, robust and scalable models, compositionality, and interpretability. Previously, Marzieh was the NLP-ML research lead at Zeta Alpha Vector, working on smarter ways to discover and organize knowledge in AI. Dr. Fadaee received her PhD from the University of Amsterdam, where she worked with the Language Technology Lab, a research group focusing on information access from natural language data. She previously received her BSc in computer engineering from Sharif University and an MSc in artificial intelligence from the University of Tehran. So a very warm welcome to you, Marzieh. I apologize for the audio issues. So at this moment, the audio might change, but I'm turning it over to you. Thank you so much for your talk today. Oh, with the title, Mastering Language Understanding with AI, How Multilingualism Shapes LLMs. Thank you so much.
Yeah, thank you. I'm going to start on low. I hope you are adjusting your voice settings so I'm not too loud. Hi, everyone, and thanks for the great introduction. I'm very excited to be here. Good evening from Amsterdam, morning in Toronto. And let me just first make sure that my slides, I'm hoping full screen looks good. Great. Okay, so and just give me 1 second. Right. So what I want to talk today is about language understanding in the age of AI, and in particular, how multilingual research has helped to advance the field of language understanding with the current large language models that we have. Let me start by this famous word from the Austrian philosopher Wittgenstein. The limits of my language mean the limits of my word. This is something that I do believe is also true for the AI models that we have. So as we increase the number of languages and the information from natural language that these models have, we are expanding the word that they have and they see, and potentially their capabilities. And that's what my talk is going to be about today. So there are a few things that I'm going to discuss. One, I want to start by exploring actually the path of research and innovations that led to where we are now with the, in particular with the architecture of large language models, which is a transformer. Then I want to discuss some of the current challenges and open questions that exist with language models. And then I want to, in the end, point out about why it's important that we should still continue working in a multilingual frame and on multilingual problems to advance the field of NLP and AI in this area. Well, so first, let's start by what are large language models. I think by now, probably most, if not all of you have some experience using ChatGPT or some other models that are now getting more and more popular and available publicly. So language models essentially are neural models that get as input a large amount of data, in this case, in format of text, and then they can generate content. So they can generate coherent, plausible sentences in the language that they were trained on. And they are quite impressive. So what they can achieve in terms of different numbers of tasks that they can do is quite large, and it's getting also more and more broad every day with new research that's been going on. So we have the typical chatbots, which can be like something like ChatGPT, but also in a particular domain or for a particular customer or company, you can have chatbots. Then there are different fields of like biology, for instance, where large language models have been used really effectively. One thing that is really, I would say, very impressive is in computer programming and how, with the help of language models, now we can code faster, potentially cleaner. They can help to write programming code, but also to debug, identify problems in existing code. Another application is creative work, which is quite, the sky is the limit of like what you can do with these sorts of models. Like you can do idea generation, brainstorming, come up with a bedtime story based on the events of your day for your children. And it's also other applications in different fields, such as like law, with like legal documents, legal question answering, in the field of medicine, how they can help, potentially they can help doctors and medical associates, and yeah, all sorts of other applications. So they are really quite impressive, but they're also not perfect. So they do have problems too. They tend to make stuff up, hallucinate sometimes, so talk about things that are not factually correct. They can be tricked, I would say, maybe to generate harmful content. So there can be also like inherent bias that exists in the data that you have, that these models actually multiply and showcase. So there are some in different areas based on the content and how they are used and the content that they generate. They can have some potential issues and challenges. Another aspect that might not be as much talked about, maybe I would say, is actually the focus of these models on just like English language and also like the I would say culture of English speaking countries. So that's something that it's very impressive what these models can do, but it's not really accessible to a lot of other people who don't speak potentially English language, or like a few high resource languages. And this has led to just like a snowballing effect of like models that are really good at English, and then all of these really nice applications and follow-up works that are built on top of that, that would only also focus on English. So we do want in this talk to talk about the limits and the open questions that exist in the current area of large language models. And I think it's important to understand how they work first and where they come from first. It actually started, like the first original language model started more than 100 years ago. So Markov proposed this idea that you can predict whether the next letter in a book is a vowel or a consonant based on co-occurrences of vowels and consonant in a large, as in like in a book, large amount of text. And then a few years later, Shannon actually had the idea of applying these n-grams to do next word prediction, which is very much the foundation that language model, nowadays language models are also built on. So essentially what we have with language models is that we have a really nice system that can generate coherent, plausible sentences, one word at a time. And what helps it generate these sentences is the context that it has, so like the previous words that it has, and also a probability distribution that it predicts, that helps it predict the next word. So essentially, and not surprisingly, language models, they model language. But let me just take a step back and really think, let us all think about what we mean by modeling language or understanding a language. So if you think of a child that is growing and learning a language, they would learn to do different things once they master a language. So for instance, they would be able to identify the subjective information that exists in a sentence, which in the NLP field, it would be called the sentiment analysis task. They would be able to answer questions in that language. It wouldn't necessarily be always correct. It depends on their knowledge and the correctness of their factual knowledge, but they can generate answers in that language. They can also make a piece of information shorter, summarize it, or if you a bit like more complex would be to understand inherit, for instance, like entailment relations between two sentences, which comes first, which comes second. And then if you are lucky and you speak more than one language, at least two languages, a complex thing that you can do is translate from one language to another. So translation is not really that straightforward. It's quite hard. It's really, there are a lot of different complexities when we talk about translation, depending on the source language and the target language that you pick. It can be that there are no, so like for the same word and concept in one language, depending on a lot of different things, like the context, the use case, the translation might be different. So it's not really like a one-to-one or even like one-to-many or many-to, like a straightforward line of word-by-word translation. Words and phrases also can move around in different languages. So reordering is a important factor of like the particular order of words is an important factor of each language. And you have to have this knowledge once you want to translate into that target language. There are also different nuances in a language that might be hard to capture and hard to grasp. So you can have like a language that is gendered. So you have like gendered nouns, and you have a language that is not. So when you translate this, you still want to do that correctly. So assigning the correct gender to the noun, but maybe now you have to use pieces of information from the rest of the sentence because that's the gender is lost in one language. So there are a lot of these complexities in translation. And I think translation is actually a great example to assess whether a person or a model has a level of language understanding, because you need to be able to read and write in two different languages. And in this process, be able to transfer meaning, hopefully fully and faithfully and completely from one language to another. So we have the field of machine translation for years now, for decades, that has been focused on developing models and systems to do translation, essentially. So it started from like way back with rule-based MT systems. And in a more recent past, the statistical-based machine translation systems, or the SMT models, have been really be the status quo of machine translation. And all of the research has been focused in this framework, the SMT framework. Up until 2014, where we start to see deep learning models and neural models coming into the field of machine translation. And it was also essentially the first introduction of arguably neural models to any task in NLP. So it was in machine translation. Coincidentally, also 2014 is the year that I started my PhD in the field of machine translation. So when I started, like the history and the status quo was the SMT systems. And then the new papers in NMT were coming out right at the start of my PhD. So I was very much, I saw firsthand with each of these papers that I'm going to talk about briefly next, how they impacted the field of MT as well as NLP, and then broadly leading to the large language models. So we had SMT before, we still do, but up until 2014, they were like the state of the art in machine translation. And they use phrase-based, there are phrase-based translation models. They use phrase tables, which is essentially pairs of translations of phrases in two different languages. And that's based on the probabilities of whether, how often this phrase aligns with this other phrase in another language, they do the translation. But actually a component that these SMT systems also had was language models. So this particular component would help the fluency of the generations in the target language. So that was the use of this particular probability and component in SMT. And actually the name of large language models, it goes back to 2007 when there was this particular paper on not neural models, but the classic n-gram models, but very large, that has been used for years in SMT. But then we come at 2014. So I started my PhD, and then there was this paper. This paper by people from University of Montreal and Mila and University in Germany, they are one of the first to actually look at using neural models for machine translation. And the idea was to have an encoder and a decoder. The encoder would encode the source sentence, the decoder, the target sentence, and they use recurrent neural networks to capture the recurrency of language, that one word come after the other. And they use this neural component in addition to SMT to rescore translations. Then the same year, this paper by Google came out, which similar idea, having an encoder and a decoder to get like the representation for the source and the target sentences. However, they do direct translations, not really as additional component to the SMT system. Performance-wise, they were almost there. They were not really very close to the SMT models at the time, but they were not quite there yet. And then in the same year, back again with some of the authors of the first paper, the third paper came out, which actually introduces the concept of global attention to the recurrent neural network when you do the encoding. And the idea here was that for the decoder who is generating one word at a time, the target sentence would pay, at each point that it wants to generate, would pay attention to the full source sentence. So with this additional information, it will generate hopefully more accurate sentences. And this is actually one of the instances that, one of the first instances that a neural-based MT actually outperforms the SMT model state-of-the-art at the time. However, this is under the condition that if you exclude the Ankh token. So Ankh token is actually something that was the problem of the neural models at the time, which I'm going to revisit later on. But this has been quite impressive, showing that this like global attention is can help improve the translation qualities. Then 2015, there's this paper by Stanford that they looked at global attention, but they also introduced local attention, which is only paying attention to a subset of words in the sentence. You don't necessarily have to pay attention to every word. So making this local attention much more focused based on what you are translating. And this work showed quite nice improvements, again, compared to previous SMT models and the NMT models, like the last three papers that we talked about. But also when you do Ankh replacement. So translation quality was getting better in just like a span of 1 year with 3 to 4 papers. But they did have one major problem that the SMT models, they didn't have. And that's I call it the Ankh problem. The root of the problem is that, so translation is an open vocabulary problem. So you have to be able to generate any word. So you don't have like a closed vocabulary in a language, right? But for NMT models, you have to have this predefined set of vocabulary to train these encoder-decoders. And you can have this quite large. So you can, for instance, for the English language, if you have the vocabulary size at 50,000, then you are covering 95% of the text in English. But when you go to a language like German, that's not enough at all. So the solution at the time was essentially to replace these words, and they're usually rare words like names of people, names of places, to replace that with the Ankh token. And then the output of the neural models would look something like this essentially. So losing the high information of things like proper nouns by just replacing them with Ankh. But the next work and the intuition behind this work is that the maybe words are not the best unit to work with, and maybe subwords can be used, and subwords can still have a lot of useful information. So if you think about like compounds in the German language, or just like in morphologically rich languages, subwords still have a lot of information. So in 2015, there was this paper by University of Edinburgh that they proposed. The idea is based on the byte pair encoding compression algorithm, and they proposed a segmentation technique for words so that the number of ANC tokens become almost zero in the output of these neural models. So already in a span of a year and a half, we have quite nice improvement in translation. And then in 2016, it was very impressive what NMT models could do, and they become publicly available. So Google replaces for 9 languages, the Google Translate, the traditional phrase-based system that they had is replaced with their neural models. Microsoft also released this human parity achieved paper for Chinese. So it was a really like a highlight of the advances of neural machine translations becoming available to public. But the systems were far from perfect, and becoming accessible by everyone, they led to also some problems for people as a result of mistranslations. And in some cases, it became actually a serious problem. So 2016, and then we are in 2017. It's already like 2 years into NMT. Things have happened that for the SMT, it took like decades. And then in 2017, people at Google, they released this paper called Attention is All You Need. And they propose a new architecture called a transformer. They removed the recurrency, the recurrent neural network idea, and they introduced the self-attention. So expanding on this idea that attention was really a key factor in improving these models. And with self-attention and also providing parallelization, they achieved state-of-the-art performance on machine translation and very impressive results. And that's all she wrote. So like 2017, this paper came out. And since 2018, with the BERT and GPT papers, the people have started using the transformer architecture to develop different models. And these models, up until now, they are all based on the architecture of transformers. And they're also in different modalities. They can be text with large language models, but also like image models, video, and speech. So it has been quite some time that the architecture of transformer has been used in a lot of different areas and different modalities and problems. And as also the time has passed in the last few years, the sizes of these models have been, the number of parameters that they have been increasing as well, given the availability of the computational power that everyone has. So why actually transformer became transformer? So I think it's the attention mechanism itself is really quite impressive in deciding where to focus and make predictions based on that. By removing the recurrency, it can also, it's more straightforward to apply this architecture to different modalities, so not just text. One key factor, like I said, is being able to parallelize the computation in this architecture, which makes it much more scalable and allows for these high number of parameter models to develop. And they're also, they do work quite well, so that makes them very desirable to adapt to different NLP tasks. So what let's talk about the LLMs now, large language models. We have the architecture of transformer as the main architecture of these models, but there's also a lot of other bells and whistles that go into training these models. So usually a general recipe for these models is that you have the pre-training stage where you have billions and billions of tokens, raw text that you would feed these models. And the idea is that the model is learned to generate the next word based on the previous words. And the idea is that this would help the model understand the grammar, the meanings of the words, the more like surface level information of a language. Then in the second stage, what we usually do is we fine-tune these pre-trained models with labeled data. And sometimes it's called instruction data, sometimes it's just like question answering data, prompts, completions kind of data. And here the idea is that the size of data is smaller because it's labeled data, so you have to have some annotations there. But the idea is to teach the model to do different tasks. So if you are given a question, you want the answer. If you say summarize this text, you provide an example of what the summary looks like. So the model learns to perform all of these NLP tasks that we have been seeing with the language models. And then third step is doing some sort of preference training. And this often involves human annotators. And the main goal here is to align models in some particular scenario with human preference. So this can be to make models safer, but also can be just like so for instance, you can imagine that if you want your model to generate longer sentences rather than shorter ones, this step of providing 2 examples to the model, one short answer, one long answer, and saying, I prefer the long one, would hopefully, and then fine-tune this model in using RLHF or similar approaches, would helpfully result in a model that aligns more with what you prefer as the annotator. And yeah, all of these blocks are essentially transformers from the old field of machine translation. And the advances here are quite impressive. Just this year, this graph is already outdated. There have been new models out, but yeah, there are like many different types of language models that have been released or to different extents every day. And it has also become quite a powerful tool, which many companies and startups had started leveraging large language models and build on like end user applications or tools for using them that is still going and growing every day. So let's go back to the earlier point, what we were talking about. So the point of multilinguality and understanding different languages, and whether these very impressive large language models that we have now, whether they are the ultimate universal translators that we were promised in Star Trek. So let's talk about language models and how multilingual they are. As I said earlier, most models are primarily focused on English, and for good reason, because they are built on top of data, and the amount of data is important, the quality of data is important, and English is vastly available to train these models. Some of these models exhibit some multilingual capabilities despite being primarily focused on English. There also have been some multilingual attempts at building multilingual models, but there are a lot of challenges with building these models in a multilingual way. The main one, or one of the challenges, is the curse of multilinguality, which is actually, it has been shown to an extent that with the same size of model, if you increase the number of languages, your performance decreases. So you do need to scale the size of your model as you also increase the number of your languages. And there's also, like I mentioned, the lack of data. But it's also not so so gloomy. So even with the models that have been focused on English, what happens sometimes there is this incidental bilingualism, which has been shown, for instance, for the Palm model by Google, how in the training data of this model, there are many examples in other languages other than English, as well as actually paired examples of translations. So the model during the pre-training stage has the option of potentially learning these other languages as well. Yeah. So we were talking about translation. We talked about that a lot. So how well are these models at doing translation? So this is a really nice work that they looked at ChatGPT and a huge range of languages from high resource to low resource. And they showed that for high resource languages, ChatGPT does really comparable performance with other machine translation focused models. But one thing that is interesting, and you see here, is that they use the number of Wikipedia pages as a proxy for how low resource or high resource a language is. And also the performance of ChatGPT in translating that language. And there is quite a clear divide here. At the bottom, we have a lot of hexagons with like blue and green, which are the low resource one with fewer number of Wikipedia pages. And at the top, we have a lot of red and yellow with high resource ones. And the top ones are the better quality translations. The low ones are the lower quality ones. There's also the question of cost, which I didn't really touch, but it's very important. And it is an important factor that as these language models, they become larger and more powerful, you also need a lot of compute to support them, and that becomes costly. So especially in the field of translation and how the performance is, whether the differences in the quality of translation justifies the cost or not, that's a big question. There's a lot of other advantages of using, of training language models, or just like models in general, on multilingual data. So one phenomenon that happened and has been shown in quite some cases that happen is this cross-lingual transfer. So as you have more languages in your data, it can be that the information from one language can help the learning in the other language. Sometimes it's based on the languages being from the same family of languages, but sometimes it's also not really like languages from two different families, but still there's some transfer of information that happens in the learning process. One other main challenge for multilingual models is the factuality and how well they know our word, essentially. So you can imagine that a lot of the like the primarily English models, you can ask a lot of factual questions of them about who is the president of the US, or like some geographic questions. But if the so for instance, if you want to train a model in Persian and the data that you have is just translating the English data to Persian, the factual information that you have is still about the English culture. So it's not about the Persian culture. So this is an important factor as we build more multilingual models, that we also have to have region-specific and culture-specific factual data as well, and not just transfer from English primarily to these languages. And one last thing that I want to talk about, which I think is quite important and quite interesting, is how, so we might think that, okay, so there are some of these low resource languages that these models are not really, they don't work well for, but does it only affect people that speak that particular low resource language, or does it can or potentially can affect everyone? And this is an interesting work that they showed how you can prompt a model, an English model, GPT-4 in this scenario, to generate harmful content. So these attacks here are just like asking harmful prompts or like triggering the model to generate harmful content. And they showed that if you use the language of the prompt, if it's in a like high resource or mid resource language, then the number of successes for the attacks are quite low. But if you do that in a low resource language, the model would very easily just generate harmful content, which can very easily also be translated back to English. So this deficiency of performance in one language can potentially also affect all of the users of that language model, which makes it important additionally to work on a lot of different languages. Yeah, so I talked about multilinguality and large language models. And I do want to finish by talking about a project that we have been working on for the past year at Cohere For AI. So the AYA project is a multi-institutional project on building a multilingual language model, collecting the data, and building a model, which our focus is based on using the help of the community. So really trying for each language that we want to include to have people representing that language who are familiar with the culture and the nuances of that language to help us build this data by giving us examples and doing annotations and quality controlling of the data that we have. And as you can imagine, it's quite a challenge. It's not really an easy task, but we do want to support 101 languages. And we have been working on this for the past 8 months now. And the plan is to release the models and the data that we collect here as an open source resource for people in the community, as well as researchers that can build on top of. And I just want to briefly show you how, like why it's important to have these specific examples in different languages to build a multilingual model. So here, for instance, you see like examples that are actually translated from Turkish. So the original example is in Turkish, but you see how we just a few hundred examples that we had for the Turkish language, we were able to fine-tune this model in a way that the outputs of these language models are now much longer and more natural and organic, which is something that we prefer. And we also have been showing so far, this is an ongoing project, but with our intermediate models, we have been showing improvements of performance in different NLP and natural language inference tasks for most of the languages in our list, and a little bit of decrease for the very high resource ones, the 4 languages that are the highest resource. But it's not, it's very a small price to pay to have a model that has quite an impressive performance on 90-something plus other languages. And as one of the members of this project said, is really this particular project is about a small group of people who are passionate about their language, and they want their language to be represented in the current state of large language models. And we hope that a lot of people can benefit from this data set and models that we release by the end of this year. Right, so as closing thoughts, I just want to wrap up by summarizing what I have been talking about. And I thought to I think one main takeaway that I want everyone to know if they don't is language understanding is really hard. It is very impressive what these models do. So I asked ChatGPT to generate a joke about language understanding being hard, and it did quite well. It's really, I would think it was unthinkable like 10 years ago when I was doing my PhD. But the joke is also actually true. So we are expecting these models to understand natural, like human language, but we are providing them very limited resources and list of clues. They don't interact with the environment. They don't have the history and the culture and all of the information that comes with language. So it is a still not fully solved problem to make these models better at language understanding. And there are some existing challenges in the current model. So one is the factuality and truthfulness of these models. So how, so they might, they're still not really 100% always telling the truth. So based on their data and how you prompt them, and it is becoming hard to tell whether it is generating hallucinations or truthful facts. Another important challenge in this field is evaluation. So like, for instance, here in an example, you see we have like two different data sets that these models are evaluated on. And one particular model, it performs really well on one data set, and it performs really bad on the other one. What does this tell us? What does this evaluation process, like how to compare models, how to identify the shortcomings and the pitfalls of these models is still a challenge. The next one, I think, is red teaming and safety. So how to deal with the misinformation that these models can generate, how to deal with harmful and toxic content that can be now potentially generated at a scale. These are all open questions for this field. And then lastly, I want to touch briefly on data. So what these models use as data, as well as just like what in the format, but also like quality. Then there's a question of how much is actually necessary. Do we need these trillions of data, or can we actually find a nice subset that we can use to have better or similar performance? Also, there's a question of data governance and copyright issues, and who owns the data, and like who can use the data in what format. So these are all open questions and open challenges in the current state of large language models. And I think they are maybe even like tenfold more extreme and important when you talk about multilingual models. So all of these problems you can imagine in all of the languages of the world. So the main takeaway from my talk that I like everyone to leave with is that large language models are quite impressive. They're remarkable at what they do. And they are what they are partially, but very importantly, based on the architecture of Transformer, which was built by open research and sharing research in the field of machine translation. So I think the multilingual framework is really complex, and it provides a space to, once you address the challenges there and try to find solutions there, this can actually contribute to the improvement of models across the board. And I also do believe that we should continue working in a multilingual framework, and it's not really because of just like helping communities that don't speak English, but I think there's very beneficial factors for everyone once these models are more multilingual than just like focusing on one language. And that's something that I'm hoping everyone can take away from this. Right, that's my talk. Thanks, everyone. I hope I was on time. And yeah, I'm looking forward for the questions and discussions.
Thank you so much. Thank you. That was a wonderful talk. Okay, we already have some questions, I think. Oh, was that? Okay, great. We'll go to the discussion period. So just to review the procedure, if you can use the raised hand function in Zoom, then our team will ask you to turn on your mic. You'll receive a request in the Zoom link. Okay, so let's start with Michael John, please.
Yeah, thanks for the great talk. I really appreciated the history of what happened, like beyond just the most few recent years of large language models. So my question is, when we're trying to improve performance, multilingual performance, do you think there are other avenues besides collecting high quality and more data in other languages, or is that the primary lever we do have to use?
Yeah, thanks. I do think data is a huge bottleneck there. So if you think about, well, first unlabeled data, so just like pure, like regular text, which for many languages we do have, but for a lot of languages we don't. But when you also talk about labeled data, like these sorts of like question answering, these pairs of data that these models learn new tasks essentially, that is really very few amount of them that are just like scarily very few in different languages. So in this AYA project, we started looking individually for each of these languages, what are the like native, like a university at a particular city somewhere built a small data set, whether we can use that or not. It was really hard to collect and very size-wise very small. So making the learning process of large models with high number of parameters on these small data sets also a challenge. And I think once you get past that, the evaluation in each of these languages, that would be the next one, because you might get away with noisy, not so perfect data for training these models. They have been shown that they can also deal with partially some noise. It might even be beneficial to them. But once you talk about evaluation, you need clean gold data that has been curated for that particular purpose. And usually, I mean, like I can maybe generate a evaluation set for like 1 or 2 languages that I speak. But beyond that, I can only guess. So I think individual people that speak that language with their background and that culture are the best to generate these sorts of, for instance, question answering that is relevant for their language and culture. And once you add these individual people to the equation, it's really hard to collect this data.
Okay, thank you. All right, so next question is from Ishtiaq, please.
Thanks, Marzieh. A great presentation. I liked your presentation and also like the research that you presented to us. It's very timely, very important. I actually have like two questions for you. I also agree with you that to improve these models, we need more data from these low resource languages. So I'm from Bangladesh, and like in Bangladesh, this kind of like movement is going on, like I'm making an open repository for Bangla language. But at the same time, there is also a voice of protest that's raising, because by making this data open and available, we are allowing this big companies like Google and Amazon to make business on our data. So my question to you is, how do you see this kind of like big tech politics unfolding if this low resource communities, they open their data to them? So that's number one question. Number two is about the conflicts when you like bring different languages together in terms of translation. So in one of my own projects, we are looking at different translations of Islamic religious text of Quran, and we see people are coming up with different translations for the same language. So when these kind of conflicts happen, how do you resolve that? How do you make sure that the interpretations of the most marginalized communities are heard? So thank you.
Yeah, thanks for the question. So the first question is actually a very, I think, active, open question in general. So for instance, with this, like the AYA project, we have been also discussing in the community with everyone, what is a good license to release this data set and the models, because we wanted to release it in an open source way, but like what would be like non-commercial or commercial, like academic use, differentiating between them. And there has been, like, some people were for just fully open source. Some people were thinking that, yeah, maybe commercial use on this collection that was just like really curated by the love of a lot of these people and volunteers might not be the best. So personally, I am tending towards the fully open source. I think it is very, we can just like discuss all day, but actually my experience here was that it's in this project was that it would have been much easier if we wanted to pay annotators in each of these languages to get this data for us. So like big tech companies, they also have the resources to do that. We went the harder route of just like asking people, trying to build the community around building this collection, not just because it's something that the big tech companies cannot do, but because of really trying to bring the passion of people, especially in research, together. And then hopefully by releasing it open source, it can be that a lot of cool individual projects and applications come out of this, but it can be that it also partially becomes like part of the next GPT model that OpenAI trains. But to be honest, especially for these low resource languages, I would love for that to happen, for these larger models from the big tech companies to actually be more multilingual, to have these examples in different languages. But yeah, it's a very open discussion, I would say. And then for the second question about the conflicts and the ambiguity of, I think that's a very valid point. For a lot of the cases, it is that there's like one fact and that fact is correct, but I think it's on the minority. There's a lot of, with language, with the creativity and ambiguity being part of the language, there are different interpretations of the same piece of text, and being, I think the important thing is that not really trying to find the best one or the one that represents everything, but being able to allow for all of these different interpretations to be part of your data, hopefully, and then your model learn that, and then based on maybe your use case or like how you want to, because you might also want to see like 5 different interpretations of this particular verse or this particular poem, like anything that you know. So being able to do that and not really deciding on behalf of the people what is right, or like the gold truth and what is not. Thank you.
Great. So next, Elliot Krieger, if you had a question.
Hi, Marzieh, great talk, thank you. So one thing that struck me in your description of the kind of history of machine translation was an acknowledgement from the technical community of some intrinsic ambiguity in the translation problem. And I guess I just wondered what you think about some of these more recent technical, I guess, objectives or kind of community efforts to promote things like truthfulness, or even more broadly, like alignment in these technologies. to me, those seem also intrinsically ambiguous. What it means for a statement to be true would depend a lot on different types of context, and some of that context may or may not be possible to infer from the text you're observing. So yeah, any thoughts you would have on that would be interesting to me.
Yeah, thanks for the question. I think it's very relevant. And so how I see it is, at the core of this alignment or preference training, you can align for any or like a lot of different objectives. So like one can be, like I said, with like preferring longer text to shorter text. So that might be less controversial, I would say. But then you can also essentially, that's the place to introduce your subjectivity to the training of these models. And by your, I mean like the companies or the people that are training these models. And that is where like this subjectivity can be, for instance, what you define is toxic and what is not, like what is like bias and what is not, for instance. And then providing examples to the model and amplifying that definition that you have in the model. So if the model before was doing both cases, like sometimes this, sometimes that, you are just like picking, there was this one work that they theorized that there are like multiple distributions exist in these pre-trained models, and by alignment, you are essentially like trying to make one distribution more bold than the other ones. And in order to do that, you are introducing your subjectivity. So how much it aligns with like the wisdom of the crowd, or like the general definition of truth and good. And it's a very, I think, open and philosophical question. And I especially don't think just a few engineers have to decide that. It's very much one of the reasons that I think making models open source is important, so that we have different points of view in the trainings of these models. Yeah, I think that's very much the by trying to make these models more specific into what they think is good, they are losing some of the ambiguity and the nuances and what these models can do, which is by choice by a lot of these companies. Yeah, but I guess the question is whether it's good or bad, or yeah.
Okay, great. I'm going to go to a question that is in the chat. This is from Sharon Ferguson, and Sharon isn't able to turn on their mic, so I'm going to read the question. It's connected to, I think it kind of follows on from Elliot's question. Sharon asks, I'm interested in one of the current challenges that you mentioned, safety. As multilingual LLMs need not only know the language, but also have cultural knowledge, what do you think we need to build in safety protections, into those safety protections to multilingual models, to the extent that they've been developed in primarily English LLMs?
Yeah, that's a very good question, and I don't think that many people are there. There hasn't been that many research work in this area. There are different parts that makes it tricky. So one is to actually have this the cultural knowledge and culture sensitive information of what is safe, what is not, what is toxic, what is not. I use an example often that I think maybe in more like Western countries, it's very endearing for someone to call their baby like my little monkey, or like if they want to just like say he's cute. In the Persian language, it might count as offensive to call anyone like a baby or anyone a monkey. So there are these nuances that comes from that you can not also get from translation. So you cannot just like translate the existing safety data or toxic data to another language and hope hope for the best. You can, like, that's a starting point, but you cannot only do that. So I think that the challenge is first to have people with the knowledge and with the background to provide annotations or to point to data points that can be useful there. But there's also the fact that these, so that's for like making these models better, hopefully for training these models. But then in the evaluation, you also want these safety checks in those particular languages with those particular backgrounds. So really trying to build, so for instance, with red teaming, there are a lot of, now there are some companies that they provide annotators to do red teaming for different models. And where the annotators are from is very important then in this scenario. So the language that they speak, as well as where maybe they grow up to be familiar with that culture. Yeah, I think there's fundamentally the lack of data from my point of view is something that is really stopping us to do this. So the first step would be actually trying to create this data for as many languages as we can.
Great, thank you. So next we have a question from Hayani Daman. And Hayani, okay.
Hello. Yeah, thank you for such a wonderful presentation. That was fantastic. It was riveting, actually. And I have two related questions. And the first one's a little bit abstract. So I'd be curious, I guess, just to hear any thoughts or reactions you might have on the question itself. And then the second one's a little bit more concrete. The first question being, LLMs were developed in the context of English being the lingua franca. And so there, there's a sort of path dependence there, and they will be adjusted and perfected to English. But I'm curious to know, if we were starting today, if anybody sort of looked at what the optimal language would be, what it would look like, what the grammatical structure of it would be, and that being the very abstract question, then the related concrete question being, well, are there languages which are widely spoken, but where prediction is much more difficult? And so where it looks like any progression as far as LLMs are concerned would be quite challenging. Thank you.
Yeah, thanks for the question. I really like that. So what is the optimum language? If you ask me, I would actually say a language that is really complex. So if you look at, for instance, the Ankh problem that I talked about. So even before the solution of BP or like other word segmentation techniques, the translation to English was okay-ish. Like you didn't have that many Ankh tokens in English. But actually what really was suffering was English to German translation because of the compounds in German and just like the huge number of words that you have. So once a language is complex like that, then it introduces new problems. And then by working on the solutions, you end up having much more stronger models. So I think from my point of view, and that's also like one reason that I think working on multilingual problems is important, is because of how each of these languages can bring different complexities and different challenges to these models. And of course, the quality is low in the beginning. Of course, there's a lot of bad examples of bad generations. But that's actually the point that then research needs to happen to start working on these individual problems. Yeah, I think that would be for me, optimum language is the most complex, or like putting everything together. And then your second question, yeah, I think I missed that. Can you just repeat very quickly?
Yes. So conversely, are there languages where prediction is much more difficult? Maybe because of, I don't know, maybe the language is too ambiguous, or it's not very complex. But where you then think that even though these are widely spoken languages, any progress as far as LLMs are concerned would be quite difficult, just because there's so much ambiguity in the language.
So I think I'm not sure about the exact numbers in terms of like widely spoken, but one thing I have experienced is, especially with this, the factually correct predictions, that's something that these models really struggle with. A lot of very common, maybe not the highest resource and like most spoken, but very common languages. Common as in like very like mid resource, like a lot of people speak that language. And it's like very like silly examples, like asking for in your like native language for a recipe of a dish that is specific for that. So you don't really need creativity there. You don't need like a lot of different, you very quickly can know whether this model knows your culture or not by how well it knows that particular dish. And I think for most languages that we tried, it's just like it comes up with new recipes that maybe also like seems odd in that language for that particular dish. So yeah, there's quite a bit of challenge still for many languages in the world. And another thing that also makes it challenging is, so you can imagine now these, like we have one model for like 100 languages, right? And then if you look at the word level and the token level of what we have, the script of these languages are different. Even like the left to right, right to left, how you write is different. So for a word or like a subword that is maybe with the Greek alphabet and happens in a lot of maybe like English, but also like Spanish, French, these sorts of languages, that word, the prediction of that word is quite good, probably. It has been seen a lot. But for a particular, maybe like Chinese character or like Persian word, that it has seen much less of that in the training data, the prediction of that would be challenging. And we ask the same model to do both. So of course, it's going to be better at one and bad at word and bad at the other one. So yeah, the hope would be to address this issue, and it can be at different places. So it can be at how you tokenize, how you combine languages with different scripts in one model at the input level, but also later on in the model in your training, or like even in the alignment stage. I feel like there are like different places that different improvements can happen for non-English languages.
Okay, thank you. So our next question is from Phil.
Yeah, my question is actually related to that. First of all, I want to say that I'm a neophyte in large language model, but I'm interested in the ambiguity of words and how that involves the hiddenness or the disclosure of that ambiguity. And it seems to me that I'm looking at words as kind of like hubs, like a transportation hub. It could either be just a terminal, in other words, it ends there, or it could be various sizes of hub that connects to multiple other words, other cities, so to speak. How do you deal with a situation that, in a sense, that you want to not allow words to either be a very limited connection between other words and other things, and to particularly to just being a terminal to something that could nuance the relationship of multiple connections, because it's always the case. And this is particularly problematic if, let's say, ChatGPT is like looking at the prediction of one word related to another word at a time. Okay, you could still get at that by having just a diversity of, let's say, multiple computations. How do you make that translation of, let's say, allow the word to disclose its multiplicity of possibilities? It seems like that's a very challenging thing. I think you already began to answer that. Could you say something more about how you attack that problem and see that almost any word is connected in multiple ways? They're all hubs to a certain degree. That's it.
Yeah, thanks for the question. That's a really nice perspective of like looking at words as these hubs and connections. So what I can add there is, I think how you describe like individual hubs and stations or like terminals and then connections is maybe fundamentally the co-occurrence of words together. So if you have like an ambiguous word by itself in a vacuum, how would you define it has like 5 different meanings, like it can be, or it has just like one meaning? Even us as a human being, we have to map that either to like a visual, like it has like these 3 visual meanings that are just like very different than each other, like a very classic example of bank, like it has like the bank of the river, or like the bank as like a place to go, or like as a concept, like a place to have your money there. So it in a vacuum, it doesn't really has that meaning. It doesn't really have that meaning, but once you have the context, it can be like the words or the visual grounding, then the co-occurrence of that word with other words will help us see whether this is just like one hub, one particular terminal, or it can be like hubs for many others. And I think the hope is that at pre-training stage of these models, this is what the models learn. So if you have just like, essentially, if you can read all of the books in the world, what you probably will then know is that which words come together in which context to an extent. But it's not really, it also very much, I think, boils down to this philosophical question of what is language, what language represents, and how these models, we say they understand language, what they are actually capturing. Is it just this surface form of text, or do they actually understand the meaning of what they're saying? I really don't have an answer there, but I think it's really interesting to think about and like try to see whether we can formulate that or model that in some way to measure that or to understand that a bit more with these models.
Okay, thank you. So we have 3 more questions. We'll see if we can get through those. A question from Joseph Bullock.
Hi, yes, I appreciate the presentation. Thank you very much. My question's pretty basic, actually. There's these knowledge cutoff dates, obviously, that, with things like ChatGPT. What's the technological solution to that, as well as the hallucinations? And then the second question I'll ask you is that, how do they approach, maybe generally speaking, sentiment analysis?
Yeah, thanks for the question. So in terms of about the knowledge cutoff, so there is a concept of time, right? So when these models are trained, they know now and before, and they use the data that has been existing in this period. And then what to do like 6 months later when we have a new president, like these sorts of information that can change in time. There are different ways of doing that. So there is the field of continual learning. So the idea there is to essentially pick up existing models and then continue the learning process for them with new data. There are, of course, challenges there as well. So one thing that can happen is called catastrophic forgetting, where essentially with new data that you train the model, the importance of the older data might get lower, and the model might forget that information. So you might not want that to happen. So there are like different ways of addressing that as well. But I think that's one way of dealing with that. I know there are some research area of model editing as well. So if you want to like inject or introduce new piece of information in your model after training, you can do that. I haven't really worked in that area, but yeah, trying to keep these models up to date and not go stale, that's very much an active field of research. And then you ask about hallucinations. So yeah, it's very much a known problem. And it can also be for happening for different reasons. It's not just for one reason. And also I think the definition of hallucination is also a bit different depending on who you talk to. So I think it's very important in this field to really try to unify what we mean by hallucinations, what are the instances, because like if, for instance, you have like the question 2 + 2, and then if the model says 3 or it says like 5 million, which one would you consider a hallucination? Because one definition is an answer that is plausible but incorrect. So in that case, it would be 3. So if you don't know the correct answer, you are still thinking it might be true. But then another definition of hallucination might be that it's just like something completely random that doesn't make sense, which is having the 5 million answer. And then the reason why it happens, it can go back to what the model has seen in the data. And there has been very much also active research there of how to deal with these situations. I know there has been one work that actually showed that the models, they do hallucinate to an extent, but once you feed that hallucination back to the model, they know whether it's wrong or right. So after generating that incorrect example, they were more capable of saying it was actually not correct, but while generating, they would end up doing that. So yeah, there are like different ways of dealing with that, and very much an active research. And yeah, I think your last question was about sentiment analysis, which is essentially quite like just by seeing examples, you can teach models new tasks. So in the fine-tuning stage, if you are interested in sentiment analysis, then you look at existing data sets or you create one. But there are like, for instance, IMDb reviews of movies. So you have like examples of like someone wrote a review and then like the number of stars. So you know whether they like it or didn't like it. So you can get these sorts of data sets and then fine-tune the model to be able to learn whether like a piece of text is positive or negative or what is the sentiment there.
Okay, so I think we have, Jameson, I think if you have a quick question, we do have a few more minutes. Jameson,
Sure,
yeah.
Sure, thank you. That was a wonderful presentation. Very informative, particularly about the ChatGPT and your discussion on hallucinations and pointing out that hallucination, depending upon which arena, could be viewed as helpful, like in the creative arena, versus politically. I mean, even the use of the word hallucination is almost asserted like in a political way, where we know it's just a lesser probable occurrence of a meaning of a word, for instance, since we're talking about words. But I'm more interested in, is there a regulatory body that will help someone like me as who goes to a position or goes to someone who relies on ChatGPT or this type of technology to produce legal advice, that will regulate that so that everybody's in the same understanding of what things like hallucination mean, so we don't have people thinking things might be like the word toxic. In your culture, it might be toxic, versus mine, it might be, a synonym for a word of a term of endearment or something. Do you know of anything in your research? Have you, just know of anywhere we could find this stuff being standardized?
Yeah, that's a good question. I think especially in these cases, the examples that you gave, it's more or less like how also in research, in open research, how it happens is that if like some people do it in a standard way and share it with everyone, and it's comprehensive and good and standard, then people will pick it up. So that's usually like when you want to have like a new definition of something. But in a broader sense of, because there's also like a lot of other, like the toxicity, for instance, you mentioned, or just like the question of data governance is very important. So it's really, it goes beyond like me and you who are just like training these models. It becomes about the policymakers, like about the people who, because like these models, essentially they rely on the information on the internet, and whether it's fair or not to use part of this information that is maybe like personal data, like these kind of things. And there has been some efforts on trying to make, trying to bring people together that are people in this field that can potentially have these sorts of documentations released, or like some policies that they can share, so that they hopefully they can agree like on some definitions and some ways of going forward, and then share that. I think at the end of the day, a lot of this is based or relied on the good faith and good actor behavior of people in this field. So if you, because enforcing it would be really hard, like if you want to enforce this particular definition that you have to use and you have to do this model, or just not only definitions, but just like rules of like what data to use, what not to use. But yeah, it's a very much an open question, I would say, like how to deal with this thing now that has been really evolving very fast in the past years, and how to more importantly make it safe for people that are the users of these models.
Thank you so much. So we have more questions in the chat and raised hands. I'm sorry we won't be able to get to everyone. So much interest in the topic today, and thank you so much, Marzieh, for your talk. So to everyone also in the audience, thank you for attending, and we'll give a round of applause to Marzieh for this wonderful talk. So please also join the Schwartz Reisman Institute next week, October 18th. We have a talk by Professor Regina Rini, Associate Professor of Philosophy at York University, and Regina will be talking about defining the ideologies of the digital century. So we look forward to seeing you all then. Thanks everyone for joining us today. Wonderful day. Bye.
Thanks for having me. Have a good day.
Thank you.